Hey everyone, so today we're going to do a tutorial video. This video is going to be on a integration question. This might look really straightforward, but it's actually a monster of a question. Integrate x squared over x to the power 4 plus 1 dx. Right, so let's get started because this might take a while. Okay, how do you go about this? First thing you should realize is this kind of slightly looks like a tan inverse if you were to integrate it. Something similar, so maybe answer should have tan inverse, but that's just a suggestion. Like at this point in time we don't know, but yeah, I'll get straight into it. Right, the first thing you want to do is actually times it by 2, so we'll see how this comes about later. You times this by 2. Of course, if you times something by 2, you have to divide it by half so that you don't change the number, the fundamental of the question. Afterwards, 2x squared is the same as writing x squared plus 1 plus x squared minus 1, x to the power 4 plus 1 dx, x squared plus x squared 2x plus 1 minus 1 is 0. So it's still the same thing, we're not changing the maths, it's still the same. Right, group them together, x squared plus 1, x to the power 4, x to the power 4 plus 1 plus half, x squared minus 1, x to the power 4 plus 1 dx. Yeah, so what we did here was we split them, turned them into two integrands. Okay, what you want to do next is divide. So divide the numerator and denominator on both integrand by x squared. So when you divide this, divide by x squared on numerator and denominator. So what you want to do here is we divide this by x squared, we should end up with 1 plus 1 on x squared. And if you divide numerator by x squared again, you should get x squared plus 1 on x squared dx. So we're not changing the fundamental here. It's still the same number, but in different form. Same thing over here. 1 minus 1 on x squared over x squared, so x to the power 4 divided by square. Same thing. Okay, and you got your dx. Right, then what you can actually write is on your denominator, you can actually write this in a different form, and that different form is where the magic begins. So another form of writing x squared plus 1 on x squared is x minus 1 on x. You square that, so if you square this you get x squared minus 1 on minus, let's see, 2 times x times 1 on x, which you get minus 2, but we never had a minus 2 to begin with, so you add a 2 here, then minus 1 on x squared, minus 1 on x squared, that you still end up with 1 over x squared. So it's still the same thing. Again, you do the same thing on the right side as well. 1 minus 1 on x squared, still the same here, but in this case, instead of minus x minus 1 on x, you put 1 plus 1 on x. Square that, and then you subtract 2 instead. Okay, and here's where it begins. On the left side, you can actually let, so actually on both integrand, let u equals 1 minus x, du dx equals to 1, so integrate that, you get 1. And if you integrate this, you actually get 1 on x squared. Okay, of course dx is then du over 1 plus 1 on x squared. And what do you see? This is the exact same as your numerator. You can actually cancel things out. On the right side, it's pretty much the same, but instead of we won't let u, we'll go v equals x plus 1 on x instead. dv dx equals to 1 minus 1 on x squared. See, this is the exact same as the numerator, so you're going to be cancelling things out very soon. dv over 1 minus 1 on x squared, and then you write it up again and you get half 1 plus 1 on x squared, and in this case we let x equals 1 minus 1 of x, so we just let u square plus 2 times by du over 1 plus 1 on x squared. This will cancel out, and you also add half. Same thing, 1 minus 1 on x squared. We're just copying from the top here. V squared minus 2 dv over 1 minus 1 on x squared. Okay, and what you can do afterwards, of course, this cancels out. Same over here. And what you end up with is 1 half times 1 over u squared plus 2 du plus half 1 over v squared minus 2 dv. That should be dv. Okay. From this point on, I'm pretty sure you guys should be able to recognize immediately what the first integrand is. That is your tan inverse. So yeah, it did look a little bit like a tan inverse so from the start, but now you do have a true tan inverse. Your numerator should be a root 2 because your a squared here is 2. Your a should then be a root 2. U squared plus 2 du. Of course, if you have root 2, you should divide by root 2 as well. On the v side, it's actually not a tan inverse because you have a minus. So this one is slightly different, and it's pretty much your partial fraction. A squared minus b squared, so that's v minus root 2, v plus root 2 dv. That's 1 over 2 root 2. It's tan inverse of u on root 2 plus half. And in this case, to do your partial fractions, you just have v minus root 2, v plus root 2. I'll do the shortcut. If you want to do the shortcut for partial fraction, refer back to the video. Leave a link on the description as well. Let this be root 2. So root 2 plus root 2 is 2 root 2. So it's essentially 1 over 2 root 2. Yes, this is starting to look quite ugly. Negative root 2, same thing. So negative root 2 minus negative root 2. 1 over 2 root 2 dv. Okay, and yeah, you just end up with all these mess. U over root 2 plus half times by log e v minus root 2, 1 over 2 root 2. You can take the 2 over root 2 out if you want actually. 1 over 2 root 2 log e v plus root 2. And then afterwards you should be able to get your answer. Sub your u, sub your v back in. 1 on 2 root 2. We know u was x minus 1 on x, so that's x minus 1 on x over root 2 plus 1 on 4 root 2 log e v, which in this case is x plus 1 on x, x plus 1 on x minus root 2 minus 4 on root 2 log e x plus 1 on x plus root 2. And there we go. You can probably simplify the log out. We've minus them, so it's this divided by that, or you can just leave it here. And that's pretty much it, guys. How to get from here something that looks so innocent into a monster of an answer. And of course, actually, don't forget your plus 3. And that's it for today, guys. Thank you for watching.